Hey everyone, today I want to talk about the unit circle. Probably the most important thing in mathematics, ever. Maybe not the most important thing, but pretty close. So there you have it, right? It's certainly, arguably, one of the most important concepts in trigonometry and pre-calculus. Now certainly, the unit circle and trigonometric functions have long-lasting effects in calculus and above, so this is really where all of that kind of takes place. It provides context to all 6 trigonometric functions and their values as we go on in time. Now, what is the unit circle? Well, if you figured it was a big circle, that's probably right. It is a circle on the coordinate plane. So we have our coordinate plane grid system, our XY coordinate plane, with a circle that is overlaid on top of it. And that circle has a center at the origin, so 0, 0. This circle has a radius of 1 unit. So on the coordinate plane, which I'm going to show you in a second, every point that lies on the circumference of that circle is 1 unit from the center. What does the unit circle tell us? Well, it actually tells us a lot. Number 1, it gives us angle measurements in both degrees and radians. Number 2, it gives us ordered pairs for every point that lies on the circumference. And number 3, it obviously gives us leeway into finding out more about our trigonometric ratios and the functions themselves. There's the unit circle. It's a lot. Dive into it. Love it. Take a picture of it. Print it out. Put it on your refrigerator. Better yet, make a poster of it and hang it in your room. I don't have one in my room, so I probably wouldn't do that. But take a look. It's complex. There's a lot of things going on here. You can see that at the 4 corner points, or the 4 top points here, we have values of 1, 0, 0, 1, -1, 0, and 0, -1. You can see a lot of information. We've got degree measurements, we've got radian measurements, and we've got coordinates. Well, there's 2 ways to learn and memorize the unit circle. One of them is by looking at it and just memorizing it. But that's not fun. More importantly, that doesn't help you. It doesn't help you dig into the concept of the unit circle in general. So we're going to actually construct it. And how do we do that? Well, remember those special right triangles we talked about? Yeah, we need them. We need them bad, actually. So to construct the unit circle, we're going to use both sets of special right triangles, 45, 45, 90, and 30, 60, 90. This is actually really painful, kneeling down a little bit more. So let's move on. Here's our unit circle, and it is on the overlay of a radian measurement. You can kind of see the grid lines that are from angle points, and you can see other circles here. The most important circle is obviously this teal colored one. This one that's kind of in the middle here, that's radius of 0.5. That is not important. I just couldn't get rid of it. So without further ado, let's try to construct this stuff. First, we want to understand that we are in the overlay of the XY coordinate plane. X-axis clearly here, Y-axis here. Remember that the unit circle is of unit 1. So from 0, 0, which is the center, every point that lies on this circle is 1 unit away from its center. So let's start constructing some things. This point right here is 1, 0. The point up here is 0, 1. Here, -1, 0. And down below here, I was really far off. 0, -1. It's hard when there's the overlay here. Okay. Now, again, we can make the center at 0, 0, just so we know what we're talking about. All right, now, there are angle measurements that are important here. Remember our special right triangles. We have a 45, 45, 90, and we have the 30, 60, 90. Which means we need measurements in really these 15-degree increments. But we're not going to start at 15. We're going to start at 30. Now, again, it's kind of hard to see. So let's actually cut this 90-degree angle, which is each one of these coordinate parts, in quadrants. Let's use the 45 because that one's a little bit more pronounced. So, let's see here. That is going to be our 45-degree angle. Again, it's from the x-axis up. We are in quadrant 1. Okay. This is a 45-degree angle. We need 3 things when we construct the unit circle. We need the degree measurement, we need the radian measurement, and we also need to find out the actual coordinate pair that it lands on the circumference of. So, remember that we said that the radius was 1. This is 1 unit. We want to find out this coordinate, which means we want to find out its distance along the x-axis dotted line and the y-axis dotted line. In other words, I want to find what the value is here and the value is here because that's how I get my coordinates, right? So we can do a couple of things. Number 1, we can use SOHCAHTOA and trigonometric ratios as we know so. That's probably our best bet. So if we have, I'm going to erase this and put it somewhere where we're a little bit more comfortable with seeing it. Let's say this is the 45-degree measurement and we have 1 here. Well, let's recall what our 45, 45, 90 triangle gives us. That's a 5. Well, if this is x and this is x root 2. Okay. Well, here's our 45, 45, 90. It's the same exact thing. The hypotenuse is 1. So if 1 equals x root 2, let's divide to solve for x. So 1 over the square root of 2, we have to rationalize the denominator, root 2 over root 2. That's going to give us root 2 over 2. Huh. Well, remember that in a 45, 45, 90, both of these side measurements need to be the exact same distance, both x and x. Well, root 2 over 2 is this distance, and it's that distance, meaning that is the coordinate pair that this point lies on, right? Root 2 to get to this point, and root 2 up. Our coordinate is root 2 over 2, comma, root 2 over 2. That is the first major coordinate pair of our unit circle, right? Because if I solved when our hypotenuse was 1, I simply got our value here. Now, let's convert the last thing we need, the degree measurement, to a radian. Well, we also know how to do that, right? So if I want to convert 45 degrees to radians, I'm going to multiply by pi over 180, which gives me 45 pi over 180. Simplifying this, and you can't see that, is going to give us pi over 4. Pi over 4 is the radian measurement of this angle, which means now we have everything that we need. We've got the degree measurement, we've got the radian measurement, and we've got our coordinate pair. Now, that took care of the 45 on this part of the quadrant. Let's go back to 30 because we need to get the 30 and the 60 in this quadrant, and we can kind of finalize where we are here. Now, I'm going to just erase these parts here, except for the radius of 1. This measurement was 45 degrees. Every single tick here is going to be increments of 15. That means this measurement here, from this dot to the origin, these aren't bad, by the way. This is going to be a 30-degree angle. So, I need to follow the same steps in order to find this coordinate pair. Now, that was our 45, 45, 90. We're actually finished with that 45, 45, 90. Now let's recall the measurement ratios for our 30, 60, 90. For our 30, 60, 90 right triangle, 30 opposite of it is x, the shortest side of the right triangle. The opposite of 60, or right next to the 30, is my x root 3. And then 2x represents my hypotenuse. Well, let's apply it to what we've got here. This is the hypotenuse, and this hypotenuse is unit 1. because every hypotenuse is going to be 1, because every hypotenuse is a radius. So if I have 1 here, let's solve for x to identify the other two angle measurements, or side measurements. I'm sorry. So if we know the hypotenuse is 1, that means 2x will equal 1, because the hypotenuse is 2x of our ratio measurements here, but the hypotenuse is 1. That means we're going to set them equal to each other. I'm dividing by 2 on both sides. That means x is going to be 1/2. Now remember what x means. X is the shortest side of this right triangle. That means this distance from here to here, or vertical, is 1/2. Okay. Let's try to find the long side now. Remember that x is 1/2. Then I'm just going to substitute this 1/2 into this x and solve. So this is 1/2 of root 3, or root 3 over 2. I don't have to do any other simplifying there, because there's no radical in the denominator, which means the horizontal distance here is root 3 over 2. So I've got my values here of this dot, of this coordinate point. It's going to be my x value of root 3 over 2 and a y value of 1/2. We're getting somewhere. Now, we can do some more parts of the trigonometric ratios in a minute, but let's complete this part of our quadrant, and then we'll move on. All right. Now, we want to get the 60-degree measurement. So, in fact, we're actually using the same right triangle. We're just going to be identifying or highlighting a different portion. So, again, 30 degrees, 45 degrees, 60 degrees. So, here. I'm going to erase this and this now. This measurement is going to be our 60-degree angle. So, this is going to be 60 degrees. This is 30. And now I want to find out this coordinate point. Right? Let's back up a second. I totally had forgotten. How come you didn't tell me? We know that the 45-degree angle is pi over 4 radians. Okay? So our 45-degree angle was pi over 4 radians. But what's the 30-degree angle? What's that in radians? Working out the process, we're going to get pi over 6 radians. Okay? So we shortcut that for a second. Moving back here, we want to find the coordinate point for this ordered pair here. So we have a 60 degrees here. Remember that the hypotenuse is 1, because again, the hypotenuse represents the radius of this triangle. So if I have a hypotenuse of 1, I still know that the x value is 1/2. Okay? Now, 1/2 is this distance, which is the horizontal distance, or my x value. Now, if that's going to be my 1/2 value, and I want to plug in the value here, I'm still going to get root 3 over 2. Now, what the difference is the order's flipped. Instead of it being root 3 over 2 comma 1/2, it's completely the opposite. Because the horizontal distance, or the x value of this coordinate pair, is 1/2, the y value is going to be 3 over root 2. So I have my values here, 1/2 comma root 3 over 2. Now, 60 degrees, if I converted that to radians, I'm going to get pi over 3 radians. All right? So, let's just finish the rest of this triangle. We know that 1 comma 0 is here. That also represents 0 degrees, which is 0 radians. I don't have to write 0 radians because we can understand by the 0 degrees. The 0 comma 1 up here is 90 degrees. Now, we want to convert 90 degrees to radians. So my 90-degree measurement is going to be pi over 2. Okay? Or half of pi, because 1/2 rotation of our unit circle is going to be pi radians. So half of that is going to be pi over 2. Okay? So what have we done here? We have constructed one full quadrant of the unit circle. Now, trigonometry also helps us with the ratios here. But for purposes of this video, we just want to be able to construct these pieces of it. Now, here's the beauty of the unit circle. I know what you're saying to yourself. I still got 3 more parts to go. Well, yes and no. Beauty about the unit circle is that it is symmetrical because we are talking about a center at 0, 0 with symmetry on the y-axis and the x-axis. See, we can just kind of roll over this part here and duplicate it, and we can roll over this part here and duplicate that. So let's go ahead and do that pretty quickly. If this is quadrant 1, this is quadrant 2. We are still going to use these 3 base angle measurements, and everything stays the same except for the signs. They are going to change. Also, what's going to change are the degree measurements, right? So let's think of it like this. These are in 15-degree increments, and this is a 90-degree angle, right? So I could certainly fill in the rest of the unit circle for you, but I think with symmetry, you can do it on your own. So look out for another video coming on soon, but for now, see you later.